Hi, my name's Olivia. In this third installment of Team 7480's programming series, we're going to learn how to use Robot Builder to create the framework for a more complex project structure. And up until this point, we've used exclusively PWM speed controllers. PWM stands for pulse width modulation, and it works by sending waves to the motors, and depending on how long the wave bends at high points or low points, the motor will go faster or slower. This does work to control the motors. However, in competition, nearly every team uses CAN. So to do this, you basically daisy chain all of your motors and CAN devices together, and then you assign each device a number on the CAN bus, up to number 250. Ultimately, CAN allows for more complex messages to be translated to your motors and other CAN devices. However, in order to take advantage of this functionality, we must first download some vendor libraries. So right now, I'm on the CTRE page for the Falcon 500 motor, which is what we're going to be using today. We're under the Tech Resources tab, which I will link to in the description. So from here, we need to download the Phoenix installer. So you can press on that, and it will bring us to this page where we can download the installers. So we'll choose the most recent version, and then we'll let that download. Once we've downloaded the installer, we're going to navigate to it in our downloads folder. We're going to extract it, and then we're going to run it. I've already installed this, so what you have checked here might differ from what I have checked, but we're going to be using C++, so you don't need to check LabVIEW, and then you can just keep whatever is checked automatically. Now we're going to start this project like you start basically everything in FRC programming, and that's by clicking the W icon in the top right hand corner. And then we're going to press Start Tool, Robot Builder. It will then prompt you to fill in name. It's not talking about your name, it's talking about the name of the project that you want to create. So we're going to be making just a simple tank drive. That's what I'll call it. And then our team number is going to be 7480 or whatever your team number is. Now you'll see this window. You can see here we have a project hierarchy. So we have tank drive, which is the overall name of our project, and then we have empty subsystems, operator interface, and then commands. So the first thing we need to do is create a drive-based subsystem. So to do that, we'll right-click subsystems, add a subsystem. We'll call it main drive. Now that we've made our main drive subsystem, we need to add some motors that can actually move. So to do this, we add controllers, speed controller group, and then we'll add 4 Talon FXs, which is the built-in speed controller on Falcon 500s. We can see that speed controller group is written in red, which means that there's a problem with our speed controller group. So by hovering over these red bars, we can see that we've assigned Falcon FX1 twice to 2 different speed controllers, which will cause a conflict. So we'll change these to 5, 6. Now we have a main drive, but in order to use your main drive, you're probably going to want some joysticks. So under operator interface, we'll right click and add a joystick and just keep it joystick 1. And we already have an autonomous command that was already built in, so that's good enough for us. Now we want to generate some code. So in order to specify where this code will be generated, click on tank drive, and it will say export directory, and that's where we'll export it, and that's good enough. So I'm going to press this C++ icon, and it will generate code to that directory. Alternately, if you wanted to try and generate some Java code, you could press Java instead, but since we program in C++, we'll be going ahead with that. Now that we've generated our code, we'll go back to VS Code and we'll open the project that we just generated. And voila, here's the code that we just generated. And you can see, contrary to the WPILib automatically generated projects, so now instead of having just one file called robot.c, we have several different C files. We have one for the command, some for the main drive, and then we also have header files corresponding to each C file. And if you want to take a look at this code, you can see that they have these begin auto-generated, end auto-generated sections. That means that Robot Builder will generate the code in between those two comments, so you don't want to type anything in between those comments if you want to make changes to your program in Robot Builder in the future. Speaking of changes, let's imagine that we want to change the name of our speed controllers. So currently you can see we have Talon FX1, 5, 6, and 7, which is not very descriptive. So let's say that we want to make that front left, front right, rear right. To do this, you'll go back to Robot Builder, you'll click on your Talon, and you'll change the name to what you want it to be. And then you'll do that for all of the other speed controllers. Once you've changed the names of all of your speed controllers, you can regenerate the code by pressing C++, go back to VS Code, and now you can see that all the names have changed. So it's as easy as that, but again, if you change any code in between the auto-generated comments, then it will not work, so you'll have to be careful with that. Now to make sure that this code works, we'll press the W and build robot code. So our build failed, and it generates an error message, so we can see what that error was. So it says, no such file or directory for CTRE Phoenix. So if you recall, at the start of this lesson, we installed the vendor library for CTRE. However, we forgot to incorporate it into our program. So to do that, you press the W, surprise, surprise, press Manage Vendor Libraries, install new libraries offline, and then you'll press CTRE Phoenix. Congrats on a successful build. You now have a project that sets up a 4-motor tank drive with a joystick and an autonomous command, which is definitely more similar to what you would find at an FRC competition. Mind you, this code doesn't actually do anything, it just creates the framework for what you will want to program yourself later. Thankfully, in our next project, we'll start moving away from auto-generated projects and we'll start writing our own code to make a Mecanum drive. So stay tuned.